Describe, configure, and verify wireless roaming. Let's jump in. Now, when we have customers who start roaming and they're going across layer 3 boundaries, different IP subnets, that, my friend, is when it gets really interesting. Let's say, for example, that everything to the left here is subnet 172.16.30.0. And let's say everything to the right is 172.16.40.0. And we have a happy client. I'll put him in blue right here. And he's been given the IP address of .55 on the 30 subnet. So packets, if he was talking to the server, the packets would look like this. The traffic would go from the client to the access point to the controller, who would translate it to the appropriate 802.3 frame, go to the default gateway, and then go to the server. That's the path there. The return path would go something like this. And you might be saying, well, Keith, that looks perfectly normal to me, so what's the problem? What's the problem with roaming? Well, if this customer roams, again, our intent is to keep it totally transparent to the user. So as this user starts working his way right, as far as the topology is concerned, and further away from access point 2 and closer to access point 3, eventually he's going to reassociate, reauthenticate using access point 3. Now, access point 3, when he gets those requests, he's going to forward them up to the controller, and the controller, because it's part of a mobility group with those other two controllers, is going to know that this guy is coming over, that he is a roamer. That information is being shared from wireless controller 2, and this is now called our anchor. You know, like a boat anchor, something they throw over the boat, it lands at the bottom of the ocean or the bottom of the lake, wherever you're at, and it holds it firm, keeps it right there. Wireless LAN controller 2 is the anchor because that's the one that initially allowed the association from this VLAN for that client to go ahead and connect. As that user is roaming and going to access point 3, wireless LAN controller 3, because it's communicating with wireless LAN controller 2, it becomes the foreign controller. So the anchor controller is the original one, and this new one that's letting this user on, because of the mobility information that's being shared, is called the foreign controller. So now this computer, I'm going to go ahead and move him. He's no longer here. Now he's over here. His IP address is still 172.16.30.55. And this access point doesn't care because it's only forwarding layer 2 frames. So as frames are being sent, so let's say this PC is now still talking to the server, the frames get forwarded from the access point to the controller, who does the translation and forwards the packets on the wired network. And so when a server gets it, he still thinks, oh, no problem. This is coming from 172.16.30.55. And does this server know how to reach that network? The answer is absolutely yes, he does. And I want you to pay attention to this pink path right here. He thinks this path is exactly how to get back to that client. And that's how he's still going to forward. Now, when that reply traffic hits the anchor, the wireless LAN controller that initially had that connection for that user, a magical thing is going to happen. And I'm going to put it in red. These controllers, through a logical tunnel between them because they're in the same mobility group, the anchor is going to forward, I'll put a pink line here, it's going to forward that traffic to the foreign controller, and then that foreign controller, who knows exactly where this guy is, forwards it down via CapWAP to the access point, and then the access point sends the signal back to that client. So the client says, oh, great, I got a packet from 10.10.10.10. And if he wants to reply back and continue the conversation, this is called asymmetrical. And it's called asymmetrical because the path getting to this server, for example, from this client, goes one way, and the reply comes back a different path. Not exactly the same path. So let me clear off some of my ink, and let's go ahead and look at the path. The path going to the server from the client would go like this. And the return path would go to the anchor controller, back to the foreign controller, to the AP of the foreign controller, and then back to Bob the client. And that is asymmetric. Now let me tell you, asymmetric paths cause lots and lots of grief because of firewalls and other types of devices that really don't like missing half of the conversation. And that's why most current implementations of roaming for layer 3 are going to use a symmetric path as opposed to asymmetric. With symmetric, it goes like this. This is still the anchor. This is still the foreign. And this guy's the anchor because the user authenticated and associated initially right there before he roamed to another layer 3 network. So with symmetric, the initial path would look like this. So there's our computer. His name's Bob, I suppose. And the traffic is going to go here to here. And instead of having this wireless LAN controller just forward the packet to 10.10.10.10, it's going to go ahead and put it through a tunnel over to the anchor, who will then forward it over to the server. the return path now is going to be exactly that same path in reverse. So the reverse path would be this way, then here, then back to the foreign controller, back to the AP, and then back to Bob. And the reason we play this game is so that Bob, if he's sending packets while he's roaming, can go ahead and have very little, if any, disruption of service. This also should take less than 50 milliseconds to pull off. Again, all in the background. That's why we have happy users. They don't know about being bounced around between controllers, and frankly, they don't care. As long as their data is moving, they're happy. Or at least they should be happy. So the process of anchors happens by default when we have roaming between different layer 3 networks, and it's all agreed to and possible because of the controllers that belong to the same mobility group. Now there's a significant difference between an anchor used when roaming between layer 3 networks and something called a mobility anchor. And here's the differences. The mobility anchor is planned beforehand. For example, let's say we have a guest network, a guest wireless network, and that guest network extends through our entire enterprise. Anywhere they go, they can go ahead and get on the guest network. However, we don't want just any controller to go ahead and handle that request. So what we could do is we could say, you know what, we want this guy right here to be a mobility anchor. So these guys are all still part of the same mobility group, but now wireless controller 1 is allocated as specifically a mobility anchor. And now anytime any of these access points get authentication and association requests, they're not going to handle it directly. What they'll do is they'll take it and they will tunnel it over to the mobility anchor. And it's that guy's job to go ahead, make the decisions about are they going to connect, and that way we can place policy regarding that wireless network on that one controller. And then once the user passes the requirements, whatever the type of authentication was and so forth, and they get on that guest network, no matter which controller they're coming through, that traffic is going to be tunneled over to that mobility anchor. So if the client is right here, say it's Susan, and she's connecting to the guest network through this access point, all that traffic is going to be tunneled over to the anchor, the mobility anchor. And then if successful and they get access to the rest of the world, all the traffic is going to be tunneled back and forth to and from that mobility anchor. Another challenge comes up with static addresses. Let's say, for example, we've got a mobile user, and for whatever reason, we've given that person a static address. And let's say, again, we have the same issue where maybe this is subnet 30 over here, and we have subnet 40 over here, and other subnets beyond. If that user shows up right here and he associates with this access point, or tries to, and he's got an IP address from the 30 subnet, how's that going to work? The answer is, it's not. He's not roaming into this area. He's trying to initially connect, and his IP address isn't compatible with that subnet. So one potential thought was, okay, we'll just make sure that every single wireless LAN controller supports all the VLANs. But that could get really, really ugly. So as an alternative, if we have these groups, these mobility groups, and if we enable static IP tunneling, what happens is when a client tries to go ahead and connect, this wireless LAN controller is going to say, oh my gosh, you've got this static IP address I see. Let me, hold on a second. And what this controller can do is he can send messages back and forth with other members of the same mobility group and ask them, hey buddy, I'm looking for somebody who has subnets in this range. I've got a customer, he's got a static IP address. I'm looking for any controllers in the group that might be supporting that subnet. And the one who answers, let's say it's this guy. He responds back, we now have a tunnel. So now when this customer connects, when Wireless LAN Controller 3 gets those packets, he can tunnel them directly over to Wireless LAN Controller 2. And then from that point, Wireless LAN Controller 2 is very much like an anchor for that customer who's accessing the wireless network. And the benefit of that is you don't have to have wireless networks on every single controller for every possible subnet where you might have a static address assigned to a client. To support the static IP tunneling, it's really simple. We'd start by making sure we had several controllers as part of that same mobility group. And then secondly, we'd go to the details of the wireless local area networks where we wanted to enable the feature of static tunneling. So let's say, for example, that on this wireless network, Wireless LAN 30, if somebody connects with a static IP address, we want to make a query to our other friends in the mobility group asking them if they have IP subnets that are compatible with the static IP address that's coming in. So to do this, let's open up the details of Wireless LAN 30. And this fourth tab up on the right, the Advanced tab, we'll go there. And if we want to enable the static IP tunneling, all we need to do is click that checkbox that says we want to enable that feature, apply that change, and we're now supporting static tunneling on that wireless local area network. And we'd simply repeat that process on any wireless networks where we want to provide that feature. In this video, we've identified a few concepts of roaming in a wireless network. I hope this has been informative for you, and I'd like to thank you for viewing.